you have to use the statistical pack because your calculations are quick and there is no need for you to cut and paste the spreadsheet data. So you can just pick up the diagrams from the toolkit and incorporate in your assignment. I hope that is the difference between when you are using Excel spreadsheet and Excel toolpack. So toolpack is specifically to do the statistical calculations. Okay, I think it is a button under tools. So okay, you can invoke the statistical toolpack, and for the assignment only focus on the using that, because all these calculations, your assignment questions, you can also do using a normal spreadsheet. That is a bit laborious and time consuming. So instead use your statistical toolpack, which is inbuilt in Excel. All right. So that is the difference. Okay. Now for this question, because the data is given, so we need to calculate what is the sample mean and sample standard deviation. So I just use the spreadsheet to calculate both. Then you can say X bar is 7.093 for this data and the standard deviation for this. Okay. Then we are doing this. Okay, 95% confidence interval, because we do not know the standard deviation for the population. We are using the standard deviation for the sample. So we have to use the t distribution. Okay. So now t distribution, what is the degree of freedom? So the sample size is 15. So the degree of freedom is 14. Okay, and at 95% confidence interval means your critical level is 0.025. So if you refer the t distribution table for a degree of freedom of 14 and alpha over 2 of 0.025, you will get the value as 2.1448. Okay, so now use this value and calculate. So once you use this and calculate, the population mean is between 6.32 and 7.87. All right, so this is the calculation part. So once you do the calculation, okay, the next part of the question is asking you. So you can just elaborate the result that at 95% confident, you can spend that, the amount spent for lunch at the restaurant is between, so you can give the range of the value. Okay, so you can give the range like this. So what type of assumptions you need? What type of assumptions you need means you have to give, you need to give that the distribution should be normally distributed. So in this case, it is a bit critical because your sample size is only 15. Okay. Now, yeah. So the most important part is the calculation one. So that we are seeing. Okay. I think we have only 1 hour time, so I close this confidence interval topic, and then I move on to the next topic. The next topic is okay. Guys, can you see the slides? The next topic is on hypothesis testing. Can you see? Yes, sir. All right. Okay, so we'll move on to the next topic. As a symbolic way, I would like to complete all the topics today. Then for the next week, next session, will be totally a problem solving. So we focus based on your model question paper. So what type of short answer questions will be asked, and what type of lengthy questions will be asked, and we will be doing exactly similar questions. Okay, so that you can be more confident to face the exam. All right. So the last topic is about hypothesis testing. We are using only one sample. So when you do this hypothesis testing, so we can also do for two samples, and actually the story begins now onwards. So you have different types of testings. Okay, analysis of variance testing, parametric testing. There are different things. But for your course, I think this is the last topic. So under hypothesis testing, what is meant by hypothesis? Okay, so hypothesis is something like a claim. Okay, so about a parameter, a population parameter. So you can say that the mean monthly cell phone bill in this particular city is $42. So that is so you're writing about population mean. Okay, you're claiming that this city, the average $42. Okay, so the mean is $42. So similarly, you can use proportion to define a hypothesis. So for example, when you say the proportion of adults in this particular city who uses cell phone is 88%, or the proportion is the population proportion of cell phone users is 0.88. So this is basically a hypothesis. Okay. Now the hypothesis, we can categorize them as two. Okay. A null hypothesis and an alternate hypothesis. So null hypothesis is always written. Okay. So we write capital H, the subscript 0. Okay. So this is null hypothesis. So null hypothesis is always about the claim or assertion which you want to test. Okay. So for example, you say that the mean diameter of a bolt is 30 mm. So how do you write the null hypothesis? So in abbreviated form, we write the null hypothesis as H naught. Okay. Mu is equal to 30. So that means you say that the mean diameter of this bolt is in the process or the population is 30. Okay, when we write about the null hypothesis, you need to know one important thing, that is, okay, the null hypothesis is always about equality. Okay, and null hypothesis is always about population mean. So it is not about the sample mean. Okay, null hypothesis is only referring to the population, and null hypothesis is always about equality sign. So you will always have an equality sign here. Okay, so the equality sign can be greater than or equal to, or you can have less than or equal to. Okay, so null hypothesis will never have inequality. So this sign you will never have. Okay, I think we'll see this in the next slide. Okay, so null hypothesis always begins with the assumptions that the null hypothesis is true. So because we are equating it, and like okay in law, so you are innocent until proven guilty. Okay, so we have to test the null hypothesis, and null hypothesis represents the current belief, or you think that the current situation is better. Okay, so therefore null hypothesis always contains equality sign, or it can also contain less than or equal, or greater than or equal. So null hypothesis will never contain inequality. Okay, and the null hypothesis may or may not be rejected. So you can reject a null hypothesis. Then you can say that we can do the hypothesis testing, and we can claim that there is enough evidence to reject null hypothesis, or we can say that there is not enough evidence to reject null hypothesis. So we can reject or we will not reject. Okay, only two alternatives: reject the null hypothesis or do not reject. And the null hypothesis, as shown here, contains always equality sign. Okay, now contrary to this is alternate hypothesis. So alternate hypothesis we always write with a subscript 1. Okay, so with a subscript sign of 1. Okay, so alternate hypothesis is opposite of the hypothesis. So hypothesis will always have inequality sign. Okay, so when the null hypothesis says that the mean is 30, then the alternate hypothesis is mean is not equals to 30. So you can't say mean is less than 30 or greater than 30, but it is not equal to 30. Okay, so it will never contain equality. So none of these symbols you cannot find, but you may find just greater than, you may find less than. Okay, so null hypothesis can contain inequality, not equal, or can contain greater than or contain less than, but not less than or equal to